Now we are having a question here. Question 2 show that 1 minus sine A, 1 plus sine A over sine A cos A equals to cot A. And then once you have shown that, you are going to solve this equation for x is between 0 and 180 degrees. Now, whenever you're given that question, this is exactly what we are going to do. Then once we have done that, we are going to have part 2, and part 2 is going to involve quadratic trigonometric equation. So once we do this, we are going to now move to that one. Now, look at this. If you are given this part, what you are likely to do, or what you are supposed to do, is to expand. And we are trying to use the left hand side to show the right hand side. So we can now say Roman 1 minus sine A, 1 plus sine A, there is sine A cos A. So in order to work out this, we want to expand. If we expand this, we're going to say 1 times 1 is going to give us 1. 1 times sine A is going to give us plus sine A. Minus sine A times 1, that's going to give us minus sine A. Then minus sine A times positive sine A, that's going to give us negative sine squared A, like that. Then now, below here we are going to have sine A cos A the way it was given, sine A cos A, meaning these two are multiplied with this dot that we are having at this given point. So meaning that this part and this part will cancel out, and then we are going to end up having 1 minus sine squared A over sine A cos A, which will mean that 1 minus cos squared A, remember cos squared A plus sine squared A equals to 1. So if we take sine on the other side, we're going to remain with cos squared A equals to 1 minus sine squared A. So meaning whenever we have this, we can be able to replace it with cos squared A. So cos squared A over sine A cos A. When you are having cos squared A, that is actually the same as cos A times cos A over cos A sine A. So meaning cos A and cos A will cancel out, and then we end up remaining with what? We are going to remain with cos A over sine A, and cos A over sine A is actually cot A. So that is exactly what we are supposed to show at this given point. We have proven that this part that we have here is equivalent to cot A. Now, if you look at whatever we are having at this point is basically, because you are told hence solve, and whatever you are solving, which is equals to a half, is what you have had in the left hand side here. So meaning this part that we have at this given point, in the process of solving it, we can be able to replace it with cot A, because we have proven that this one is equals to cot A. So at that given point, you are going to take the all of this part, you equate it to cot A, and you're going to say now cot A is equals to a half. So I would like to make use of this space that we have here, of course, because we have actually shown exactly that how to prove this, and I believe you are writing all through as you are following the video. Then I'm going now to make use of this space. I will replace that so that I can be able to work out this part that we are having at this given point. So we are going to say therefore that if we are solving this part, you are going to replace this part with, so meaning our a now, our a is 3x, so we can be able to say now cot 3x is equals to a half. Now in this case, because is exactly this equation, but it's only that this part is 3x, so meaning that this a that we were having here can be replaced with 3x. So meaning we can now, because also look at the range, the way it was, the domain of the angle, the way that it was given, the domain was given x between 180 and 0. So but here we are having 3x, so meaning we can be able to transform this. If you multiply this x by 3, you are going to have 3x greater than, yeah, like that. Now you multiply this 0 by 3, because you have multiplied this by 3, this is going to be 0 degrees as well. But if you are going to multiply 180 by 3, this is going to be 540. So meaning this is the new range, the domain that we are going to use after transforming this. So we can now say this is going to be 1 over tan 3x. Yeah, 1 over tan 3x is equals to 1 over 2. So meaning if we find the reciprocal, this becomes tan 3x is equals to actually 2. Yeah, it becomes 2 like that. Now in the process of working out this, we're going to say that 3x is equals to tan inverse of 2. And this value is going to be equivalent to what? Let's see if we work out tan inverse and the angle. Always check your calculator whenever you're working out whether it's in the correct units. Is it in degrees? Yeah, this should be in degrees. So if it's in radians, you have to change that. So we can say tan inverse of 2. This is giving me 63.4 degrees. This is 63.4 degrees. So 3x, the first angle is 63.4 degrees. We want to find this angle, this set of angles. Now we want to check in which quadrant is our angles going to be. Remember we are saying tan 2. Now this is where tan is positive, because this tan 3x equals to positive 2. So we are going to check our angles where tan is positive. So we are going to say all students trust Cambridge. So meaning our angle is going to be in the first quadrant and also is going to be in the third quadrant. So it means that if we can draw a line joining this point like that, so to be this point, the first angle that we have worked out after finding the tan inverse of 2, we have gotten 63.4 degrees. 63.4 degrees. Let me write it properly, this point, so that you can be able to see. This is 63.4 degrees. So that is the first angle that we have actually obtained at that given point. So if this is 63.4 degrees, this angle down here also is going to be 63.4 degrees. 0.4 degrees. So we have said that our angle is going to run from 0 to 540. So this first point here is 0 degrees. This point is 90 degrees. This point is 180 degrees. So once we go round, we are going to arrive at 360 degrees. So next 360 degrees plus 90, this is going to be 450 degrees. If we add that, we're going to have 540 degrees at that given point. So we have gone round to ensure that we are reaching at the point. The first one is 0, 90, 180. then up to this point we have 360. Yeah, again we add 90, we come 450 plus 90, we shall have 540 degrees at that given point. So that means if we are going to find these angles, the first one is this, the next angle is the angle that moves from the x-axis all the way to this point. This angle is going to be 180 plus 63.4. 180 plus 63.4. So that angle is 243.4. So if you move all the way to this point, you will have 243.4. So we're gonna write it here, 243.4 degrees. Now the next angle is the angle now from 360 upwards. So 360, in now that angle will be in this quadrant here. 360 plus 63.4 will be this angle again, now with 360, because the angle we have here must be more than is going to range between 0 and 540. So since we were having 63.4 degrees, again we can be able to add 360, then we move again to this point, so that angle will be in the second cycle. So we're going to have 360 plus 63.4, and that's going to translate to 243 at 423. This is going to be 423.4. So this is going to be 423.4. Now if you look at that, those are the only angles we shall have, because if you move another cycle from here all the way to this point by adding 540 plus 63, it will be out of this range, the range of angles that we were having at that given point. So in order to get the value of x, so that we can be able to have angles which are within this range that was given here, we are going to divide by 3, divide by 3, divide by 3, divide by 3. So meaning our x now is going to translate to, let's work out the value of x. Our x, the first one is 63.4 divided by 3. That becomes 21.1. 21.1 degrees. The next angle here this is 21.1 degrees at that given point. The next angle that we shall have is 243 divided by 4. 243.4. 243 divided by 243.4 divided by 3. That translates to 81.1 degrees. 81.1 degrees. Lastly, we have 423.4. 423.4 divided by 3. This also becomes 141.1. 141.1 degrees. So the values of x are going to take those values that we have obtained at this given point. So now once we have answered this question, I'm going to take you through that question that we mentioned, whereby you are given now a quadratic, a trigonometric equation involving quadratics. What are you supposed to do? Now, in this question here, we are told that tan 10 tan squared y minus sec y minus 1 is equals to 0. Then you are supposed to solve for y is greater than or equal to 0, less than or equal to 2 pi. Now, in this question here, what we need to remember at this point, remember that 1 plus tan squared theta is equals to sec squared theta. You need to remember that, so that whenever we are having tan squared theta, we can be able to replace it with sec squared theta minus 1. So we can say here tan squared y can be replaced with sec squared y minus 1. So this part is the part we are going to work with, so that if we replace anywhere we have tan with sec, we are going to ensure that all the terms that we are having sec, and then we are going to form a quadratic equation. So we are going to say this is going to be 10 into bracket sec squared y minus 1, and then minus sec y minus 1 equals to 0. So that means we are going to remain with 10 sec squared y minus 10 minus sec y minus 1 is equals to 0. This is going to simplify to 10 sec squared y minus sec y minus 11 is equals to 0. So we have a quadratic equation, and I can say at this point, let sec y be equal to m, so that I can be able to form a quadratic equation. So this is going to be 10m minus m minus 11 is equals to 0, so that we can be able to solve this quadratic equation. Now, solving that quadratic equation, what are you going to have? Solving that quadratic equation, what are you going to get? Now, can say solving the quadratic, you are going to get m equals to 11 over 10, or m is equals to -1. Those are the two answers you are going to get, because I don't want to go into details on how to solve a quadratic equation, because this question is not basically dealing with solving quadratic equation. But if you solve this quadratic equation using maybe completing square method, using a quadratic formula, or even drawing the graph, and then get the solution, you're gonna get our m is equivalent to that, and 1 is going to be equivalent to that. So meaning that once you have obtained them, you can be able to substitute the values, and then you are going to say now sec y is equals to 11 over 10, and also sec y is equals to -1. So we know that sec y is the same as 1 over cos y equals to 11 over 10, right? Which implies from here that cos y is equals to 10 over 11, right? And also from this point we can say, okay, let me write cos y equals to 10 over 11, and the other one, cos y is going to be equal to -1. Now, in order to work out the values of y within this range, let us now first consider this. Let's consider that. So we are going to say that we are finding where cosine is positive. For this first part, we are going to consider where cosine is positive. In which quadrant is cosine positive? We know all students trust Cambridge. Cosine is positive in the first quadrant, and cosine is positive in the fourth quadrant. So meaning that for us to find the first angle here, we're going to say y is going to be cos inverse of 10 over 11. If you work out that, what are you going to get? If we work out cos inverse of 10 over 11. Okay, all right. We are working angles in radians, so I'll have to change that. that is actually 0. If I work out the cos inverse of 10 over 11, I'm getting 0.43. This is giving me 0.43 degree radians, 0.43 radians. So meaning that this angle here is 0.43 and this angle here is 0.43, right? So once you have done that, the first angle that we are going to have here is this angle. So y is going to be 0.43 radians. The other angle is moving from the x-axis, moving in the anti-clockwise direction up to that particular point. So that because we are finding positive angles, so you are going to move anti-clockwise like that. From this point again to this point where you have this angle is 0.43, so that's one of the angle. Then again you move from this point, you go around to where you have the second angle that we have stated. So we are going to say this angle is going to be, of course, this is 0, this is pi, and this is actually 2 pi at that given point. This is 2 pi. So meaning the angle that is remaining, because if this part below here is 0.43, then the remaining part, we can be able to say the remaining angle is 2 pi minus 0.43. So if you subtract that, you are going to get 5.85. So this angle here, this angle that we are having up to this point is 5.85 radians. 5.85 radians. Now, for this part that we have here, for the second part is cos y equals to -1. It means we're going to say cos y equals to -1. So that is y is equal to cos inverse of -1. If we just work out that direct cos inverse of -1, you always have to confirm. So that is actually going to pi radians. So the values of y in this case are 0.43 radians, then pi radians, and then finally we have 5.85 radians. So those are the only 3 answers you are supposed to have in this particular question. So suppose you are given questions for you to prove, you are given questions to do with trigonometric quadratic equations. This is exactly what you are supposed to do in order to earn all the marks. If you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload another set of tutorials, you'll be notified. See you in the next video. Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to discuss how to solve trigonometric equations. And for instance, here you are told show that cos sec theta over cos sec theta minus sin theta equals to sec squared theta. And then once we have done that, we are going to solve 2 cos sec phi over cos sec phi minus sin phi equals to 8, whereby the range of the angle is given between 360 degrees and 0. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. So without wasting much time, I want us to now get into this question and see, when you are given a question like this, what are you supposed to do? What is that you are likely to do in order to earn all the marks? Now, remember, we are having the left-hand side and we're having the right-hand side. Now, to show that, we can begin from the left-hand side and we work it out and try to arrive at where we have sec squared theta. Now, if we're given this, we're going to say Roman 1 of this, we're going to say using the left hand side to show the right hand side. We're using the left hand side to show the right hand side. So now to show that, we begin with cosec theta over cosec theta minus sine theta. Now I can be able to rearrange this because I know cosec theta is the same as 1 over theta. So meaning that I can be able to write this as 1 over sine theta, because cosec theta is 1 over sine theta, all over this one. Also I can be able to write it as 1 over sine theta, then minus sine theta, right? Yeah, I would like to make use of this space properly, because that space is not really enough. I can be able to subdivide it here. Now since I'm having this, what I can do there, I can ideally bring in the aspect of I want to get rid of this fraction. So it means that in the denominator I can decide and multiply by sine theta, and also in the numerator, because I've multiplied this in the denominator, I can also multiply this sine theta in the numerator, because at the end of the day, when you have done that, my main objective is to get rid of the fractions that are appearing in this particular question. So which means that I can now go ahead and now say, if I multiply this, these two will cancel out, so I'm going to remain with 1, because sine theta times sine 1, this sine theta and this sine theta will cancel out. I'm going to remain with 1 at that given point. If I multiply this sine theta times this part that we have here, sine theta will cancel out. I'm going to remain with 1. Then sine theta times sine theta, I'm going to remain with sine squared theta. Now, at this given point, we need to ask ourselves, what is 1 minus sine squared theta? Remember, you need to remember that cos squared theta plus sine squared theta is actually 1. So meaning from here, we can be able to show that 1 minus sine squared theta is basically cos squared theta. So this means that this equation that we are having at this given point can be written as 1 over cos squared theta. And 1 over cos squared theta is basically sec squared theta. So we have proven that indeed cosec theta over cosec theta minus sine theta is equal to sec squared theta. So that is what you are supposed to do in order to prove that. Now, you are told, hence solve this. Hence solve this. Hence solve this 2 cosec phi over cosec phi minus sine phi equals to 8. So basically here, even if they're using a different angle, here they used phi, they're using phi, and here they used theta, it's still the same thing. We can be able to divide also. Let us just now move to Roman 2 here. Roman 2. I'll say I have to move to Roman 2, which means that if I'm having this part, I can be able to divide both sides by 2 here, so that I can be able to cancel that 2. I'll have cosec phi over cosec phi minus sine phi equals to 4, right? But we know that if you are having anything that is having cosec over cosec minus sine is equivalent to this, exactly what we have shown here. So meaning that this part that we have at this point, we can be able to replace it with what? We are going to replace it with sec squared phi is equals to 4, right? So the only thing that you are going to change here is the phi from theta. And now once we have that, if we have said that we are having sec squared phi equals to 4, then in order to work out this question here, we are going now to find the square root both sides. You find the square root of this. So meaning that at the end of the day, what are we going to remain with? We are going to remain with sec phi is equals to plus or minus 2, right? And whenever you have this, we can be able to say this sec phi is actually equivalent to 1 over cos phi equals to plus or minus 2, which means if we find the reciprocal both sides, we can be able to attest and say if we find the reciprocal here and the reciprocal there, we're going to have cos phi is equals to plus or minus 1 over 2. Okay. Now, whenever we are going to solve this, we are going now to say our first solution will be cos phi is equals to 1 over 2, the positive, where cosine is positive. So we have the 3 quadrants, all students trust Cambridge. So meaning that we are going to have here 180, and this is actually 0, and this is 360 degrees at this given point. Now, in which quadrant is our angle going to be? Our angle is going to be, let me just move this. Our angle is going to be where cosine is positive. Cosine is positive in this quadrant and also in this quadrant, in the first quadrant and in the fourth quadrant. So we can be able to join a line. Let me just pull it properly. You can join a line at that given point, and another angle will be down here. So first we need to find what is the first principal, the principal angle phi. That will be from this we can be able to say phi is going to be cos inverse of 1 over 2. So we are going to ask ourselves if we just try to find that cos inverse of 1 over 2 is actually 60. So meaning this angle here is 60 degrees. So meaning that this angle here is 60, and because of symmetry, this angle down here is also 60, right? So since we are finding angle between 0 and 360 degrees, it means that we are finding angles, positive angles. So all these angles will be measured in the positive direction. So the first angle will be this angle in this direction here, which is actually 60. The other angle will be measured from the x-axis. You move all the way to this point, right? Now, since this part is 60 and the entire of this angle is 360, to get the remaining angle is 360 minus 60, and that is going to be 300 degrees. So we have the first angle being 60 and the other angle being 300 degrees. The other part that we're going to work now is when we have cos phi equals to negative 1 over 2. That's another angle that we need to work out. So we need to ask ourselves, where do we have cosine negative? That's the first question we need to ask ourselves. So this is going to be all students trust Cambridge. So cosine is negative in the second quadrant and in the third quadrant. So which means that one of the angle will be somewhere here and the other angle will be down here. So let us go ahead and try to find that angle. So first we are going to find phi equals to cos inverse of negative 1 over 2. If you work out that, negative 1 over 2, you are going to get your answer being equivalent to actually 120 degrees. 120 degrees. So meaning always angles are measured from the x-axis. So let's say this is actually 0, 360, and this is 180. Now from the x-axis, the first angle will be from x-axis up to that. That will be the first angle, which is 120 degrees. So I equals to 120 degrees, comma, another angle, because if this is 120 degrees, the remaining angle down here, acute angle down here, is going to be 60, and this angle down here also is going to be 60. So to get the second angle is the angle that is going to be in the third quadrant. So which means that we are going to measure that angle from this x-axis moving all the way to the third quadrant. So what will be that angle? That angle will be the entire of this. Up to this point is 180, then plus 60. That is going to translate to what? 240. 240 degrees. Now, you see, now we have gotten this 240 degrees. So we have gotten this set of angles here and this set of angles at this given point. So meaning that therefore our phi is going to be 60, 120, 60, 120, 240, and then 300 degrees. So those are the set of angles that gonna satisfy this equation that we are having at this given point. Okay, now further, we are told solve root 3 tan into x plus pi over 4 is equals to 1 for the range of values here, which are x is greater than or equal to 0, less than or equal to 2 pi. Now, so in order to solve this question, it's quite interesting that we have to divide it by root 3 both sides. So we're going to have tan x plus pi over 4 equals to 1 over root 3. Now, if you can look at the range that we are having here, in fact is having x only, yet inside here we are having x plus pi over 4. So meaning that I can be able to transform this domain of the angle that is given, because the domain of the angle, the angle I'm having on the equation is x plus pi over 4. But this angle I'm having here is x. So I can be able to transform this domain of the angle given so that it can be able to be aligned with whatever that I'm having at this point. So I'm going to write x plus pi over 4 is greater than. So meaning that since I've added pi on this, in order to get this part, I can also add pi over 4 plus 0 here. So we shall have pi over 4 at this given point. And also I'm going to have 2 pi over 4, 2 pi plus pi over 4. I'm also going to add 2 pi plus pi over 4. So meaning that if I can add that, let me just say 2 pi plus pi over 4. That actually translates to be 9 over 4 pi. This is 9 over 4 pi. So I've transformed the range now to be in the same format that we have here. So I can be able to say this is going to be, now if I want to solve this, I can be able to say that is x plus pi over 4 is equals to tan inverse of 1 over root 3. So I can comfortably say this x plus pi over 4 is equals to what? So if I want to find the tan inverse of 1 over root 3, this gives me in radians. Remember, your angle should be in radians so that you can be able to get the correct answer. If I work this, I'm getting actually to my answer being 1 over 6 pi. So if I'm having 1 over 6 pi, I can be able to come and write here, this is 1 over 6 pi. Now, we want to find where tan is positive. So we are going to say tan is going to be positive in which quadrants? We know that all students trust Cambridge. So tan is positive in the third quadrant and in the first quadrant. So meaning that if we say our angle is at this given point, we can say our angle is there, then also the other angle will be down here. So if this is 1 over 6 pi, let me see here, this is 1 over 6 pi at that given point, then it means also this angle on this other side here is going to be 1 over 6 pi. 1 over 6 pi, that is actually because of symmetry. Now, if you look at the range that we are given, of course, this is 0 and this is pi, and then this is going to be 2 pi, right? This angle at the top here is actually pi over 2. Now, if we are moving from this point to move to this, you are adding pi over 2, which is equivalent to 90 degrees. And if we want to now, if we have gone the entire whole cycle, we can be able to add 2 pi plus pi over 2. So if we add 2 pi plus pi over 2, we are going to get 5 over 2 pi. So this angle here is 5 over 2 pi in the second cycle. 0, pi over 2 pi. If you go around, you reach 360 degrees, which is equivalent to 2 pi. Then if you add another pi over 2, we are going to be here 5 over 2 pi, right? Okay. If we add pi over 2 again, at that point, we are going to have at this point 3 pi at that point. So we've identified that. So we have 1 over 6 pi. This side is 1 over 6 pi. So meaning that the first angle that we are going to take is the angle that is measured from the x-axis in that direction. The angle from the x-axis in that direction, that will be 1 over 6 pi. The other angle is the angle that is measured from the x-axis all the way to this point that we have here. So meaning this is going to be actually 1 pi plus 1 over 6 pi, because by the time you move this way to this point, you have covered pi radians, then plus 1 over 6 pi. So if we add that, let's check what we are going to get. If I'm having pi, then I add 1 over 6 pi, I'm going to get 7 over 6 pi. So this is 7 over 6 pi at this given point. So once you've reached here, again there is another cycle, because our range you see is 9 over 4 pi. So meaning we are going to go beyond 2 pi or beyond 360 degrees. So meaning to get another set of angle that will be at this point, I'm going to add 2 pi plus 1 over 6 pi. And that is going to translate what? I'm having 2 pi plus 1 over 6 pi. That becomes 13 over 6 pi. So this part, I'm going also to have 13 over 6 pi. So in order to get the value of x, so I'm going to be subtracting all true for each of this particular question that I'm having at this given point. So let me just move this here so that I can be able to quickly subtract and you get to see what we are having. I think this microphone is really disturbing me. So meaning that the value of x can be obtained from x is going to be equals to 1 over 6 pi minus pi over 4. That would be the first value of x we shall have. The second one is 7 over 6 pi minus pi over 4. And the next one is 13 over 6 pi minus pi over 4. So if I subtract this, the first one is 1 over 6 pi minus pi over 4. This is going to be, it will translate to negative 1 over 12 pi. The next one here, it will be 7 over 6 pi minus 1 over 4 pi, which is giving me 11 over 12 pi. And this one is 13 over 6 pi, 13 over 6 pi minus 1 over 4 pi. This translates to 23 over 12 pi. Now, if you can look at this, if I'm finding x, I want to ensure that my x is going to be between 0 and 2 pi. Therefore, meaning that this part that I'm having here is out of the range. So our x is going to take the value of 11 over 12 pi and 23 over 12 pi. And now that becomes the two answers for this particular question. So basically what we have said is that we are going to transform the domain of the values of x the way we have done here. So let us look into the next question that we covered in class so that you can be able also to get a better understanding on what you're supposed to do. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime we are going to upload further tutorials, you'll be notified.